wanted to, for a long time, give you a little crash course on how we soil test and talk about the basics of it, how we look at a map. And I am standing here with my co-worker Brad, and by one of our 4 soil test vehicles. We often use a Tahoe or a Blazer because they're a little lighter and a little more comfortable on the road than some other types of vehicles. But let's talk about soil testing just for a second. It's a controversial subject. Some people don't like it, and many others do. Soil testing is, the philosophy of it, of course, is representative sampling. We're looking for a representation of the soil out there in the field. And some people think that's not close enough. So then we've gone to zone soil testing, and we'll talk about that more later. However, we depend on our health with representative sampling, with blood samples. We depend on representative sampling for our wealth. Every time you drive into a grain elevator, they take a representative sample of your grain, and your check is based on that. So we think that's a good analogy to soil testing. A good soil test, obviously, is based on how good the collection of the cores are. So that's dependent on a good soil tester. And a good soil tester needs good equipment, good cores, and good locations of those cores. Here's a normal sized probe, non-slotted, with a somewhat used dry tip. Here's a slotted probe. We've gone more to using a slotted probe this year than we normally have. I didn't like them because they bend easier, but it's much easier to see if your core is full. Here's a newer probe that AgVice came out with. It's made by Bromide. It's a little bit bigger diameter, a little better in wetter soils, and it has a wet tip. It has a little taper to it, and so it allows it not to plug the probe so easily. Then this year they came out with a slotted bromide tip, and we get into some tough conditions. We like that a lot. Inside here is a hydraulic ram. Goes through the floor. You attach the probe to it, and so on. Most of you know that. This one is hydraulically driven with hydraulic pump on the engine. We have 3 vehicles like that, and we have one that's electric over hydraulic. There's a 4 pair of buckets that we use for soil testing 4 zones. We've done as many as 7 or 8 at one point, so you end up with a lot of buckets. The quality of the soil test, though, I want to emphasize that. We take pride in the good soil tests we take because it's a foundation to our zone management. What we'll proceed to do is we'll just drive over the field a little bit, trying to see how the field matches up to the map. The map we're looking at is a Crop Pro map divided into 10 zones from red to pink. Crop Pro gives us a choice of about 8 fields of different ratios of elevation to electroconductivity. And we picked the 50-50 field, that 50% of the data is from EC and 50% is from elevation. And we've already ground truthed it, but we know it's a good map. One thing we're looking for is the extremes. Where we're sitting, where my finger is, so we're right on the northwestern edge of a red zone. If we look over to our left, that really matches well. There's a red knoll on the northwest corner. We just want to check that out. As we approach this knoll, we are now driving through just out of a green zone into a yellow, into an orange right now, and now we just crossed the line between the orange and the red, light red. So we're happy with that. We would check out the pink zones, the salty areas, to determine if that, where it changes from dark blue to pink, is that where that line should be. Now as we head west, we're going into just a slightly salt area, and if you look at the vegetation, is about right. I want to check if you can see it. Down to the south central, there are some dark red zones which means the texture is coarser there. Now I just entered the dark red zone, and so my question is, why is it dark red? That does not seem right, because it seems actually a better soil than where we were on the light red farther north. So what I will do here, I flip back to the regular Verus map and get the Verus reading, and what we find out is that this is quite coarse textured. So that's why we want to differentiate that from the light red. The short and long of it is, after we check these things out, we found out that it's a very good map. It lines up almost like a hand in a glove. So we go to what's called the thematic chart, which shows the 10 zones. As we go through the acreages in each zone and so on, we will determine how many zones. So in this field, I chose 5 zones. We want to avoid the outside edges of the field, because there's been overlapping of fertilizer applications, probably if they were putting anhydrous out at an angle, for instance, or if the floater ended up with a big overlap on one edge of the field, or turning, you didn't shut it off, things like that. Where we drove into the field, we want to avoid that, because there could have been floaters loaded there, there could have been fertilizer spilt, compaction, lots of reasons that it's not a good place to take a core. We know the field pretty well, so we kind of know pretty specifically where we want the samples. We want to put about 20 samples in this red and light red zone. And here again, we're looking for the average of the zone. We're not looking for extremes on high and low, and then the average of those extremes would be the average of the zone. So what this does, and we'll do that, we would do that with every zone that we're going to test. And what it does is we get the right amount of probes. If the zone was like 20 acres or less, we wouldn't go for 20. We'd probably be in that 12 to 16, depending on the areas and so on. So as we go to those points, then we'll take a core at each one. And the objective is to get a good core, full core, in a location that's as close to average of that zone as we can estimate. Here's what we would do if we were normally coming onto this plus, where we'd mark to take a probe. And if you can see out the window here, we're just about onto the headland. So I'm still got maybe 20 feet to go to get to the center of that plus sign. I'm going to change the location of that core, because I don't like where I marked it. It's a little hard to see, but I hope you can see it. It's black, which is a good indication of good organic matter, basically the whole length of the core, so that's 2 feet. And so we took that sample in the green zone there, and then we went up, there was a kind of a slight knoll. This is the core from the red zone, and if you can see it here, the black ends about here, turns a little bit of a darker brown, and then a light brown, basically a clay, the rest of the distance. And the amazing thing that the two cores are like 150 feet, 160 feet apart. And so when people tell us their soil doesn't vary a lot, we have probably hundreds and thousands of examples like this where we just see it in the field every day that we're soil testing. We get excited when we pull off a field for the first time, when we've done the first layer of zone soil testing on a field, or the first year of it, because we just really get to understand that field much better. It's a combination process of ground truthing the map and laying the basis for the future years of soil testing, because we mark those points and go back to those same points every year. Some people don't agree with that, but we in general do, and that's why we take so much time with that first soil test. So we hope you've learned something about soil testing, at least how we do it. It's a lot of work that goes into it, and we're
We're proud of how we do it. One last comment I want to make, and that's when we send these samples in, once they come out of those soil test buckets you saw earlier, we send the entire sample in, because then at the lab it is dried and ground and separated at that point. We don't feel we can do a good enough job of separating it, especially if it's wet and gooey. So, another thing. So, thank you.